Welcome to another exciting day of mathematics with Mr. G. All right. So today we are going to begin Unit 6. All right. Unit 6 involves adding and subtracting fractions. Okay. Some of us may be afraid of this, but it's really not that difficult. Okay. We have to follow rules in order for us to have some type of success. Okay, so as we know, we start every unit with the vocabulary. Okay, some of this vocabulary you may have already know, but I think it's a good idea if we go over them again. All right, the more you practice, the more you study, the better you get. All right, so let's do this. So I can learn and define new words related to adding and subtracting fractions. Okay, which is what this unit is about. Um, what is what is Unit 6 about? All right, what is Unit 6 about? Well, Unit 6 about we will add fractions with the same denominators. That's the number at the bottom. We will add fraction with different denominators. We will add fractions with mixed numbers. We will subtract fractions with the same denominators, subtract fractions with different denominators, and we will also subtract mixed fractions or mixed numbers if you'd like. So we'll also use pictographs or drawings to represent these additions and subtractions. All right, these are vocabulary words that we will be learning. We're going to be learning fractions, proper fractions, whole numbers, least common denominator, numerator and proper fractions, decimal, numerator, denominator, mixed fractions, unit fractions, and greatest common factor. So a fraction, what is a fraction? A fraction is the division of one digit, right? A one digit by another digit. For this example, 3 divided by 4. That's what a fraction is. All right. It's represented by the sign A over B, okay? Where the numerator represented by A over here, that's the numerator, is divided, right, by B, this down here, right? So the numerator represents how many parts you have. If you look at this pizza, it tells you how many pieces you have, and the denominator represents how many pieces total there should be in a whole, right? This right here tells you how many total pieces you have now, right? For example, I have 1, 2, 3 pieces left, and this tells you how many pieces you should have, which is 1, 2, 3, 4 pieces in a whole. Okay, so we know that the bottom can never be 0. You can never have 0 pieces of anything, because if you have 0 pieces of anything, then you don't have anything at all. Okay, and you can never solve a problem like that. What is a numerator? Well, as we already knew, right, when we did fractions, right, we knew that numerator is the number that's on top. The numerator represents how many total parts there are, right? Keep in mind there may be more parts to the whole, okay? There may be more parts to the whole. The denominator tells you how many parts there are to the whole number, right? The whole number should have 100 in this part, okay? Down here, the whole number should have 3. The whole number should have 7. Over here, the whole number should have 3. Okay, it's kind of, you may have remembered this from third grade, from fourth grade, even third grade, even. So that's what those are. All right, what is a proper fraction? Well, we say that a proper fraction is when the numerator, the number on top, is smaller than the denominator, the number at the bottom. All right, so a proper fraction is when the numerator is less than the denominator. For example, a half, 1/5, 3/4 of 15/20th, 2/3, right? 2 part of 3, 3 parts of 4. Those are called proper fractions. On the other hand, we have improper fraction. Improper fraction is a fraction in which the uh, numerator is greater than the denominator, right? So we have more parts to the whole. For example, this right here, if this means one whole, there's supposed to be 4 parts, right? And we have 8 parts, right? 8 parts divided by 4 parts. So this is what's supposed to be the whole number, and these is total parts that we have. For example, this right here, we have, there should be 4 parts in the whole, but we have 4, 8, 12, 16, 19 parts. We call that an improper fraction. All right, and improper fractions usually turn into mixed fractions. Okay, mixed fractions where there are many parts to the problem, and you have to turn them into whole numbers. So a mixed fraction is a number, a combination of whole number and a fraction. For example, this is what this is, right? 3 times 6/8. And the way this is done is, all right, this is a perfect example. The way this done is, it said 8 times 3 plus 6 is 30 divided by 8. So that's how you convert mixed fractions into improper fractions, right? And like this. So you get an answer like this, 2 and 1/3. This is a whole number, numerator and the denominator. Same thing with up here. Whole number and the numerator and the denominator. Creates a mixed fraction, right? So it may seem complicated, but it's truly not, right? Just if you take a look at it, absorb it, right? You'll get your answers. Make sure you keep good track of this slide right here because it's going to be important for us later. A whole number. We know whole numbers are all natural numbers, right? From 1, 2, 3, 4, 5, 6, 7, all the way to infinity. There are no decimals or fractions, okay? Those are whole numbers, right? We don't want to have 1.5. We don't want to have 1 3/4. We want to have whole numbers. Least common multiple. This is very important, all right? Least common multiple, usually we use that a lot when we're trying to find a common denominator, right? We use that a lot when we're trying to add fractions with different denominators or different bottom parts, right? So we got to find the least common multiple, or we call the least common denominator, okay? So least common denominator is just when you put two numbers against one another, you find, okay, what are one number that we could put together that these numbers go into. For example, 3 and 7, right? So 3 and 7, sometimes we can multiply these two numbers to make a quick work of it. We multiply these two numbers and it gives us an answer, right? But if we do it this way, where we take the numbers, we start with the multiples, 3, 6, 9, 12. If you pay attention, the pattern is we adding 3 to every number. 15, 18, 21, 24, 27, all the way to 42, right? We do the same thing to the 7, 14, 21, right? 28, 35, and 42. But if you look, the number that's the least number that they share, the least value is 21, right? 21 is the least value. They don't have any other numbers in common until you get to 21. Right? That's why we call it the least common multiple. Over here, the least common multiple of 8 and 6, right? We have least common multiple of 8. We have 8, 16, 24, 32, all the way through 48. We do the same thing for 6. 6, 12, 18, 24, 30, 36, 42, 48, right? And we know that before 24, there aren't any numbers that are familiar. But we also can get it by multiplying 6 times 8, okay? 6 times 8, okay? So, all right, so let's move on. What is the greatest common factor? Okay, the greatest common factor, right, is the number that is the smallest amount of number, right? It's kind of funny you said the greatest common factor. is a smaller number that those two numbers share. For example, 16 and 12, right? We have 1, 2, 3, right? 1, 2, 3, 4, 8, and 16. That's for 16. Then 12, we have 1, 2, 3, 4, 6, 8. So 4 is the greatest common factor that those two numbers share, right? You're not gonna get any other number, but we don't want to use 2, 1, and 3 because we're gonna stay with the same numbers we started with. For example, if we use 16 and 12, right? If we look at these two numbers, we can't use 1 because we're gonna end up with 16 and 12. 2, we're gonna end up with numbers that can still be divided down. If we use 2, we're going to have 8 over here. Then if we use 2 over here, we're going to have 6. We could still bring these numbers down. But if we use 4 and 12, we're going to have 4 here, and we're going to have 3 here. So we don't have any numbers to divide down. Which factors do they have in common? Well, here it is. They have 1, 2, and 4 are common factors. The largest factor, that's the one we want, right? Right here. Okay. And that is the end of the slideshow. That's for vocabularies. Okay. Make sure you pay attention, take notes, and we'll be okay. All right.